All right, now let's talk about price elasticity of demand and its relationship to revenue. This is one of the neat applications of this elasticity idea. We'll be using it a lot more later in the course, but let's just see one neat application now. It turns out that revenue is related to the price elasticity of demand. Let me just make the bold statement that revenue is maximized at the price quantity combination, where the price elasticity of demand equals -1. In the next few slides, I'll explain how this is so. Let's consider a point on the demand curve where demand is elastic, and let's show that when we're at such a point that raising price reduces revenue. So let's start with a price of 8 and a quantity of 2 along the demand curve P equals 10 minus Q. Well, let's think about raising the price by 1%, then again starting from a price of 8. So the price would rise by 1%, as it says in the box, to 8.08. And along the demand curve, the quantity sold would fall from 2 to 1.92, or by 4%. Now let's just think a second. The revenue was 8 times 2, or 16, but the new revenue, if we were to raise the price by 1%, would now be a price of 8.08 times a quantity of 1.92, which equals some number, 15.5136, but the big point is that it's less than 16. So just to step back for a second, what happened was we were at a price of 8 and we raised the price by 1% and the revenue fell. Now remember that a price of 8 is a point on the demand curve where the demand was elastic, as we saw in the previous module. Let's alternatively think about starting from a place where demand is inelastic and raising the price. And what we'll see is that when demand is inelastic, raising the price raises revenue. So let's consider a price of 4. If we were to raise the price by 1%, price would go from 4 to 4.04. But then moving along the demand curve, quantity would fall from 6 to 5.96. Let's just think what would happen to revenue. Revenue had been 6 times 4, or 24, but now it's 4.04 times 5.96, which is a little bit bigger than 24. It's 24.0784. So when the demand is inelastic, that is when the price elasticity of demand is in an inelastic range, then raising the price raises revenue. So it turns out that when the price elasticity of demand equals -1, that is when it's unit elastic, that revenue, or price times quantity, is actually maximized. If we take that to this demand curve, the P equals 10 minus Q, or Q equals 10 minus P demand curve, that means solving the expression for elasticity, which is minus P over 10 minus P, solving it for being equal to -1. And so if we do that, we find P equals 5, Q equals 5 is the solution. And at that point, revenue is 25. Now I want to talk about this one more way, but before we get to that, let me just suggest the intuitive idea that the point that is the maximum is the point where we see the biggest revenue rectangle that fits underneath the demand curve. And for this demand curve, that's at a price of 5 and a quantity of 5. We have one other way to see that revenue is maximized when the elasticity equals -1. Again, we're using the same demand curve, P equals 10 minus Q, or Q equals 10 minus P. What the table shows is a set of prices and quantities along this demand curve. So for example, if the price were 9, the quantity would be 1. Look over at the last column where we have the revenue, the product of price and quantity. So 9 times 1 is 1. Then next to the last column, which has a bunch of computation in it, is just a calculation of the elasticity of demand at each of these points along the demand curve. So at a price of 9 and a quantity of 1, the price elasticity of demand is -9, and the revenue is 9. Move to a price of 8, we get a quantity of 2 along the demand curve. Revenue has risen now to 16, and the elasticity at this point is -4. We can keep going. What we see is there's something special about a price of 5 and a quantity of 5. Well, first thing that's special is that the revenue is as high as it's going to get. It's 25. And the second thing is that the elasticity of demand is actually exactly equal to -1 at that point. So this is just another way to see that revenue is maximized when the elasticity of demand is -1. And to put a fine point on it, what that means is revenue is maximized when we've chosen the price-quantity combination such that the elasticity of demand is equal to -1. So what are the takeaways from this short module? Well, first, when the price elasticity of demand is inelastic, that is, when the elasticity is between 0 and -1, then raising the price raises total revenue. When the price elasticity of demand is elastic, that is, the elasticity is between -1 and -infinity, then raising the price reduces revenue. And finally, revenue is maximized at the price and quantity combination such that the price elasticity of demand is equal to -1 or is unit elastic.